So the second section of our ecology unit starts with bioaccumulation. I'm just looking at the word bioaccumulation. I can see two parts of it. I can see the bio part of it, which when I think of biology, I think of study of life. And then I see the big word accumulation. When I think about accumulation, we talked in class about, okay, what kind of things do I accumulate? We talked about accumulating money and stuff like that, and it's kind of stuff that's building up somewhere. So when we talk about bioaccumulation, we talk about stuff building up and relating to biology. So when we look at this, we define it as a process in which a toxic, non-biodegradable substance accumulates in the tissues of an organism. You can also call it bioamplification, and we're going to see exactly why we call it bioamplification when we kind of see it on a pyramid, like on a food pyramid, or kind of when we look through the trophic levels of why it kind of amplifies the effects of this toxin. It's going to concentrate as we climb up the trophic levels, and this can have pretty nasty effects. Not everything's going to have effects exactly the same, but it can lead to things like mutations, so physical mutations. It can affect brain function, so neurological conditions. We'll see a couple of examples of those. It can lead to sterility, which would be an inability to reproduce, and ultimately it can lead to death. And obviously these two things can kind of lead to that. So when we look, we talk about, okay, it's going to concentrate as we try and climb the trophic levels, and it kind of makes more sense when we draw it out and kind of see how a substance like this would act. And we're going to look at something like a pesticide on it, and we're going to see a specific example of a pesticide called DDT that's going to act like a bioaccumulating substance. So when I look, and I've got my trophic levels here, starting with some plants at the bottom. I know the picture is super blurry. Then I've got like some mice or something, a snake, and then an eagle way at the top. So when I think I'm going to spray a pesticide on some of these plants. So let's just draw here. I've got a pesticide. On some grass or maybe some crops for a farmer. And this pesticide is going to have a substance that doesn't break down. Sometimes we call them perpetual pollutants. It's something that normally our body will break down things like sugars and fats and pretty much anything else we eat, and it's eventually going to run out of our system. Something like a perpetual pollutant isn't going to. So something like DDT, if I spray it and I'll say, and this is obviously a huge underestimation of the amount of particles there are. Let's say there's 10 particles of it that get sprayed on this grass. And you should be drawing this in your notes too, with your pencil, or I'd suggest using a color because your pencil might kind of blend in with the gray colors on this. So I spray and there's like 10 particles on this section of grass. Okay, I've got these mice that come in and they're going to be eating the grass or the crops or whatever. Now the thing is all these other parts of the grass is going to break down, like the carbohydrates, everything else in it is going to break down. They're going to kind of use that for energy, the nutrients in it. However, these little particles of DDT aren't going to break down, and they're going to kind of build up, because you think of how much grass we need to eat, and we know because of the energy transfer we talked about with the pyramid of energy, I'm really only getting 10% of that energy as I go up. So I need to eat more and more of what's below me. So then this is going to jump up, and even though we have less mice than grass, there's still going to be 10 particles here. And in the specific example of DDT, we might start to see some effects here. So DDT, as it kind of climbed up, there wasn't many nefarious effects on the plants themselves, but as we started to climb the trophic levels, and especially the more that these kind of lower level consumers would consume these pollutants, they'd start to kind of die off. It would build up in the fatty tissue of these animals. Even if they were to die, however, there would still be consumers on higher trophic levels eating them. So we've got something like this snake here. Whether or not the rat's dead, it's going to eat it. So it's going to eat either the living rats or maybe some dead rats. Thing is here, no matter how many rats it's eating, he's still getting all that same amount of particles. He can't break down the particles. So we're still going to have 10 little molecules of our DDT up here too. And now we might start to see sort of more of the effects when we talked about mutations, sterility, and death occurring. these effects are kind of coming with the molecules of DDT, but the more and more they build up, the more these effects are going to take place. And then obviously you get to the very highest level, we've got our like apex predators up here, and they're going to get still those 10 particles they're not going to break down. Probably wasn't the perfect way to draw that. There's 10 up there. So we see every single time 100% of my toxins are getting transferred. So 100% of my toxins are getting transferred. None of that's really breaking down as it goes down. So it's really going to affect the consumers that are on the top of our trophic levels, that are at the top of the food chain. And if I think who's at the top of the food chain, we're at the top of the food chain. So we should really be worried about this. If you think, well, I don't really care if a bunch of rats die because they get poisoned by a pesticide. We should care because as we climb up the trophic levels, eventually we're going to get to us. And right at the bottom of your page there, you might see that I wrote bioaccumulation of DDT specifically in birds like falcons or eagles caused fragility in their eggs. So this might not seem like a huge deal, but it actually declined the populations of those birds to near extinction because of the inability to reproduce almost. So it didn't cause sterility necessarily, but because the eggs were breaking so easily, there was less and less offspring for these birds. And I've been mentioning a lot DDT. DDT stands for, it's a long chemical name like dichloro, diethyl something or other. It just stands for the big chemical substance that it is. You can Google it and look at pictures of it. It's stuff maybe we'll talk about it more when we study chemistry, like the nomenclature of it. But exactly what it is, and I underlined the part you should be writing in your notes here, it's a strong and persistent pesticide, and it's going to dwell in an environment for a long time. So I might kind of correct what I've been saying. I've been saying it never breaks down. Technically, it is breaking down. It's breaking down very, very slowly, something that really in our lifetime, we're never going to have a noticeable amount of breakdown of it. And this was something that was kind of like a wonder chemical back in the day. You can look up advertisements for DDT. There's advertisements of people spraying it on their cereal and then eating it to prove that it's not dangerous, but don't worry, it kills the bugs. There's, advertisements, just written ones, promoting it, saying, everyone loves DDT, it's great, it's saving our crops. Obviously that didn't work out. It was banned worldwide in 2001. If you look, I even wrote, I think in Canada it was banned in 1969. So obviously like first world countries were kind of first to ban it. It is still used in some places of the world, mostly third world countries where they don't really have many other options. So they'll still use DDT, but it's under like strict monitoring. And we've also got at the bottom here, I highlighted Silent Spring by Rachel Carson. This is a book that was written by Rachel Carson in 1962, kind of highlighting the effects of DDT before everyone was really sure exactly what it was and what it was doing. Rachel Carson was kind of regarded as being a bit overreacting, and this was kind of how women were reviewed in science back in the day, is, oh, she's being hysterical, there's not really that much of a problem. The book focused on, in the prairies specifically, that when you used to go out in these fields and you'd hear bugs and birds and wildlife and stuff like that, and suddenly, and frogs croaking, and suddenly you couldn't hear anything anymore. And Rachel kind of knew, like, the alarm is sounding right now that we're killing off more than just these bugs, we're killing off everything else, and kind of, raising the flag and saying we need to do something about this. So it was really, really efficient in what we wanted it to do, which was kill off pests, but we kind of didn't look down the line and see that we were having these effects that are eventually going to reach us. And just to highlight the picture I put at the back here, this is them spraying DDT on a beach, and it says a powerful insecticide on it, they're spraying it, and there's other pictures of kids running through the spray of it and stuff like that, because they promote it as something that is super not harmful to people, don't worry about it, and in the end we're finding out it is not exactly 100% safe for people, and certainly not safe for the ecosystem, which is going to kind of cause a cascade and affect us. Whether or not it's going to directly affect us, giving us mutations or sterility or death, if it's killing off all of our food source, then in turn it's going to kill us off. So if I think of I wrote down some advantages of something like this. So reducing the insect population, so we're transmitting less deadly diseases, like something like malaria is going to be transmitted by mosquitoes. We're going to have higher crop levels just because there's less bugs eating the crops. But then we think the disadvantages, a lot of fish and frogs are going to die because they're eating these things. fat in their bodies is going to have a really high concentration of DDT, which is going to be eaten by decomposers and just by necrophages and stuff like that. And some other ones that I didn't list, I left a bit of a space down here. We can kind of think of, and I'll just write it on this slide here before we get to the next one. We can have a loss of useful insects. So I think of something like bees, that they're super useful. They're not really doing much to affect our crops. They're just pollinators. But DDT wasn't selective in which insects it was going to kill. So this was really going to kill off any insect that consumed it. Mutations and sterility is another one. And another big concern was this was kind of being used as a wonder chemical, that everyone can just use this. But the bugs are going to start to become resistant to this. So nowadays we're going to kind of rotate pesticides more to make sure that bugs don't start to get used to and adapt to the chemicals that we're using, because then once they've adapted to this chemical, we can't use it anymore. It's kind of like if I kept eating spicy food every single day, even if I really don't like it, eventually I'm going to start to become used to it and be able to eat spicy food after a while. Instead of spicy food, it's just bugs eating deadly chemicals that after a while they're going to get used to it. And another one, a big one to highlight with DDT, here I'll try and write this a bit lower here where it's lighter. Got lower bird populations. And this one kind of goes with what was on the last page. We talked about how it was causing specifically a fragility in their eggs, that we have a lower bird population. This is going to kind of cause a cascade effect all down the trophic levels, that now we don't have these birds. There's less predators for other animals which might not be affected directly by DDT. They're going to be affected indirectly by this kind of change, this shift in the food webs. And I just add this slide here. You don't need to write this down in your notes, but these are the effects that were listed by the CDC in 2011. So this is in the US. When they tested heavy green samples, they still found DDT in 60% of them, 42% of kale greens, 28% of carrots, keeping in mind that this was banned in Canada and probably the United States around the same time in 1969. So this was a long time ago. When they tested people's blood, it was found in 99% of people's blood, which is, again, something that we don't really think about. It's not having a direct effect on us now because we've stopped it before it built up to such levels, but found in 99% of people's blood. And women exposed to DDT, specifically women who are exposed like prepubescent to DDT, are 5 times more likely to develop breast cancer. So again, it's something that we didn't know exactly at the time, but now something looking back and doing the research on it, we can see that this is a chemical that we did not fully understand its effects when we were using it. Now we get into mercury poisoning. There's a couple examples from Japan, the US, and I didn't list them on the paper, but we're going to talk about them. A lot of examples in Canada. So mercury in Japan, it was used in a factory, the Chiso factory, to bleach paper. Now this is a factory that was like upstream from a whole bunch of towns and cities, Minamata being one specifically, and that's why now the effects of this mercury poisoning is being called Minamata disease. It's caused by methylmercury poisoning. So the mercury was running into the water. They were kind of dumping the mercury waste into the water once they were done with it. And this was not only contaminating the water, but bacteria in the water would take this mercury and break it down into methylmercury, which is extremely toxic. And this would go into fish. And of course, being right on the water like these towns are, they're going to rely a lot on fishing, not only for economic purposes, but also just for food resources. So only a few years or years after this had started do we really start to see the effects of what happened. I didn't include any pictures of people affected by Minamata disease. It's not just people. There's pictures and videos of cats and of fish and stuff like that. I find it kind of morbid to post pictures. If you'd like to look it up on your own, that's up to you. I just don't really like including it. It creeped me out, doesn't make me feel very good looking at it. It can cause things like ataxia, sort of a loss of peripheral vision, so you can only see right in front of you. There's damage to hearing and speech, insanity, and paralysis. And a lot of this has to do with mercury is going to cross the blood-brain barrier and it can't get back out. So it's going to affect you neurologically a lot. So a lot having to do with like your motor functions, your nerves. So that's why we have a damage to hearing and speech. This has to do with your brain. We talk about insanity. This was kind of like an interesting topic to bring up in class because you were kind of like, well, how is it exactly affecting insanity? But it's going to attack different parts of your brain, some of those having to do with, normal cognitive function. paralysis coming down to like your muscles, your nerves not exactly responding the way you want to, and obviously resulting in death. Officially, it was listed that 43 people died from this. When you look at this online, this was kind of contested a lot, that a lot of it was swept under the rug, and kind of they decided not to report on it as much as they should have. It's kind of suspected it's near like probably hundreds of thousands, if not millions, of people affected by this. But again, it's kind of hard to find research on it. It kind of gets swept under the rug a lot. If we look at the United States, again, I didn't include photos. If you look up the family, like mercury poisoning in the United States with this family, I think it's the Huckleby family. Again, it was children. I didn't feel right including pictures of them in here. So the family they didn't have a ton of money. They went and bought this grain that was treated with mercury. It was dyed a specific color to let people know it was treated with mercury to prevent fungal growth on the grain. The family bought it anyway to feed their pigs. They noticed that the pigs were starting to appear ill, but they kept feeding the pigs to the family anyway. They just kind of pick the less severe of them. They called it blind staggers. The pig would kind of stagger around, kind of showing the signs of mercury poisoning. Within 3 months, the family all developed signs of mercury poisoning, some not as severe as others. It kind of amazed doctors that some of them had very like light symptoms and some of them had very severe symptoms like paralysis. A lot of them are blind and deaf. One of the daughters ended up dying after being in a coma. And when I listed on here, 3 of 8 children lived with extreme physical and mental impairments. Those are the ones that could not function on their own without assistance. So blind, bound to a wheelchair, deaf, a lot of cognitive function. That's not to say 5 of 8 of them were completely fine. The parents ended up dying eventually of complications by this as well. So it makes it sound like not as bad when we say 3 of 8, but that's 3 of 8 that lived with like extreme impairments that had to be under constant care. The other ones, while still impaired, were not considered extreme impairments. And then lastly, I included mercury poisoning in Canada. This is one that's really not that far in the past, and it's something that we pretend doesn't happen somewhere like Canada. We pretend it's something that happened super far away or didn't happen in our times. Grassy Narrows First Nation in Ontario. It's about 40 kilometers north of Kenora. If you know where Kenora is, it's like Lake of the Woods. Mercury poisoning was discovered there in 1970. Dryden, it was a chemical factory, petrochemical factory that was, again, dumping mercury into water sources rather than disposing of it properly. Same thing that happened in Japan. This will get transformed by bacteria in the water into methylmercury. And this is, it was a paper mill company. From 1962 to 1970, they were doing this dumping, and this community, again, relied not only on this for their own food, but for a lot of economic and tourism purposes. And the people started to notice the effects of this mercury poisoning. However, the government in Canada insisted that everything was fine, the fish were safe to eat, not to worry about it. And this was brought up in class that that's kind of messed up, that the government said this was totally fine. And that's kind of like a systemic problem we have in Canada of the government consistently treating Indigenous people unfairly, because if this were to happen somewhere, like in the city of Winnipeg or even in Morden, it would never occur to the government to take it lightly and tell us that it's fine, just keep eating the fish anyway, just keep using the water anyway. And effects of this are still seen today in the First Nations community. There's children being born that have signs of mercury poisoning still, even though they've never consumed the fish that were there. And that's about it for bioaccumulation.